The purpose of this video is to show you how to use automated software to take an aircraft that you've designed in Jet10 and with that software convert it into a CAD drawing, and then also show you how to take the CAD drawing, scale it down, modify it so that it can be used to generate a 3D printed wind tunnel model. We begin with a Jet10 model, and this one is one that represents ETSCAT. This is the starting point for ETSCAT, so you can anticipate that you can do much better if you optimize. So here's our aircraft. Yeah, we want to trust this document. This is the file we're going to make into a CAD file. Well, that's good. We checked it over. It looks right, meets the requirements. We have aerodynamic data here that we want to try to match in the wind tunnel, or try to determine in the wind tunnel if this is a good estimate of what this shape will do, assuming that the wind tunnel can tell us more precisely the aerodynamics of a shape like that. So we begin with the, it's called RMET now. It might also be called JetCAD automation. Most likely it'll be called RMET, so we're going to use that one for this video. So we run RMET. Once the RMET screen comes up, we move it over here to the right because we know there's another screen going to pop up over on the left, and we don't want them. We want to be able to see both of them at the same time. We hit the first button, select our jet file. We're going to that place on the K drive. So K, and this is also where you'll start your ETSCAT design process. DF DFAN AE481 and 2019, and in the ETSCAT folder is this file that we just looked at. So that's the one we want to convert into a CAD model. So now we hit Run SolidWorks, and it'll cook for a little bit. May make a couple of exclamation sounds as it runs. It does have to load up SolidWorks, so it could take a while, especially if it's the first time you've done it. After you've done it a few times, SolidWorks comes up pretty fast because all of the environment is still loaded after you exited the other time. So it can quickly load all those things, but my computer was just rebooted, and so it's going to have to take a while to do this. But don't worry, I'll edit out most of this wait time. Alright, so the file generated, and this automated, do you want to look at the file, doesn't seem to work very well. So just X out of it and load SolidWorks yourself. We'll know where to find the model because it says right here is where the model was saved, in C:/SolidWorks data/ curve data / model / jetmodel.step, and that's the one we want to load. So let's go find it. We open, we go to the C drive, we go to SolidWorks data, curve data, model, and it's this jetmodel.step. So let's open it up and take a look at it. I don't want to run import diagnostics. I don't want to do feature recognition. but I do want to see the lines, so I'm going to switch it to this one where it shows the lines. Okay, so there's our model. Notice a couple things about it. For one thing, it didn't make the strake. I don't know why. Sometimes it does, sometimes it doesn't, but in this case we kind of like it because we want to make the strake a little different. Because stealthy airplanes have inlets, and those inlets have to be chined for low RCS. A stealthy plane like this will always have strakes. It'll be the inlets that stick forward of the wings. I say always, but the YF-23 did not have inlets that acted like strakes, but it had its own chined forward fuselage anyhow. So we want to have that strake, so we're going to draw that. We'll do that first. Now, there's several things to get used to in CAD drawings. One of them is that when I rotate the model around, I am holding down the scroll wheel on my mouse. And when I zoom in and out, I'm rolling the scroll wheel. If you're trying to do CAD without a mouse that has a scroll wheel, it's a lot harder. And I just recommend you get a mouse. And then you'll find that it's actually pretty easy to do what you need to do. One of the things to notice is, let's take a front view of the airplane. Okay, so why is this the front view? Well, aircraft coordinate system, the x-axis runs left to right from the nose of the aircraft back to the tail, and that's the front plane in any normal coordinate system. The y-axis runs out the right wing, so that's vertically up this way, so that's why this is a front view. And then the z-axis comes out towards you, and that's a standard front view in CAD. So just get used to that. It's not the front view in an aircraft. Here's a side view that ends up being the front view, and here's a top view that ends up being a side view. So just get used to that. It's useful, especially when we take this CAD geometry and do CFD or something like that with it. It's good to have the x-axis run down the longitudinal axis of the airplane and the y-axis run out the right wing. Now, a little bit about CAD. This is 3D solid modeling. This is SolidWorks software. Other 3D solid modeling software works pretty much the same way. You have to sketch something and then extrude it or loft it into a 3D solid. And these were all done automatically. We have to do the strake ourselves. So in order to sketch, you first have to have a plane. So let's think about this. We want to draw the plan form of the strake in a top view of the airplane, which would be a front view in CAD, and so we want to draw in the front plane. So notice I highlight it over here on the left, and it shows up. If I click on it, the little blue dots and lines indicate this plane is highlighted. Now I don't want to draw my sketch in that plane exactly. It's too low. That plane is at 0 z coordinate. So I need another plane that's at the height where I want to put the strake, and I want to put it right where that line is on the wing, which is like the leading edge of the wing. And so I have the front plane highlighted. I'm going to insert reference geometry, plane, and then I will create a plane at the height here that I want it to be at. It says 10 millimeters, so first off I'm going to change that to inches. Notice down here way in the lower right hand corner it says MMGS, and I should have noticed that and made the change already. But let's guess. Okay, the wing is 1.8 feet high above the zero, so let's say this is equal to we don't have to put in the equals, 1.8 times 12 times 25.4. Okay, and that puts that plane, I think, right about where we want it. Yeah, that looks pretty good. I think if we do that, and you can see where the plane's going to be, and you can see where the strake is going to intersect the fuselage, and I think that's just about where we want it to be. So we're going to, anytime we hit the green checkbox, whatever we were doing tentatively and what was being shown temporarily will be made permanent. So we hit the green checkbox, and now we've got a plane. Now we just need to draw our strake. And if you wanted to be really precise, you would go back to Jet and you'd figure out exactly where the strake is located and how big it is and where it intersects and everything. To save time, I'm not going to do that, but if you were going to make a wind tunnel model, you'd want it to be as accurate as possible. Instead, notice that I clicked the Sketch tab up here. The Features tab is how we make solids. The Sketch tab is how we draw, and I'm going to just draw a straight line. Okay, and I'm going to start here at the center line. I'm going to go forward to about there. I'm going to go at the same sweep angle as the wing is. The wing is swept at 52 degrees. And I'm going to come back here, which is what Jet will do. Now, I need to make sure that this sweep angle is 52 degrees. It says, well, it's 33 degrees. Okay, so what's 90 minus 52? It's 38. Okay, and that should be parallel now. Let's see if this one's, let's make this one also parallel. Okay, what's 38 plus 180 is 218. Okay, and let's check that one, make sure it should still be 38. Okay, so this, I think, is doesn't matter. The rear one doesn't matter. The front one, you can see, is parallel to the leading edge, and that's what really matters to us. And how far out it goes is just to the edge of the inlets, which if we went back to our jet model, we'd see it's right about there. So this is the strake we're going to model. Doesn't change the aircraft geometry very much, but it's important to be complete for the purposes of the wind tunnel model. Okay, so this is half a strake. I can easily make the other half. Highlight, mirror entities. I'm going to mirror, you have to, over here in the dialog boxes, what you're doing is blue. And so while I was picking what lines I'm going to include in the mirror, that box was blue. Now I'm going to pick my mirror about point, and I pick that point. You see it gives me a preview of what I'm going to see in yellow, and I say yeah, and also there's a checkbox in the copy so I don't just mirror it and then lose the original. So this is my whole strake, and now most of the things that you use to make 3D solids have to be simple closed curves. This one's a double closed curve, and so, but if I delete this mirror line, now it's a simple closed curve. Okay, and that can be used to generate solids. So that's what I'm going to do. So I'm going to exit Sketch because I'm happy with the way it is. Okay, now we can see it. It's in gray instead of in blue. It was in blue while I was working on it. As I highlight it, it turns orange, highlighted over in the list on the left. If I click on it, then it's going to turn blue, both on the left and in the depiction. And then I'm going to select features, and I'm going to extrude a boss. Okay, 10 millimeters. I said I was going to change the units, and I'll do that in just a minute. I don't know if 10 millimeters is quite enough. Now, there's a couple of things I want to do here. I want to put a little edge on, oops, once in a while as you're moving it around. It takes a little while getting used to moving it. You're grabbing it and turning it by holding down the scroll wheel. And as you zoom, wherever you put the cursor, that's the point it zoomed in. So you can change your view by changing where you zoom. And after a while, you'll get really used to it, but it takes a little while. So I want to put an edge on this thing. Right now, if I change this to 100 millimeters, you can see it just goes straight. It's just a slab. And that's not the way a stealthy airplane would be. Plus, it's going the wrong way. Notice this arrow here kind of shows me which way it's going, and also the preview of what I'm going to do. So I want it to go the other way, so I reverse direction right here in the dialog box. So that's good. 10 millimeters is, oh, there I did it again. So whenever I do that, I just go back to one of the standard views up there, and then I can find it again. So that's probably thick enough, but it wouldn't be the way the top of an inlet would be shaped. But I'm going to get that shape by drafting inward. So look what happens. That's 1 degree. Let's go 1,000 millimeters, a meter, so you can really see what's going on. Oh, I accidentally exited, so let me just go back into it. So I right-clicked on the thing in the list, and you see how it highlighted. And then I go back to the extrude function, and it'll let me rethink what I did. Alright, so I want to draft inward. And look what that would do. If I did it enough, it would actually make something that looked more or less like the inlets of the airplane. That's not a terrible thing to do. It's probably, and then from that we could build the rest of the inlets. And there's certainly a place for that, but really to get decent aerodynamics, it's not necessary. In fact, the inlets complicate things, and we spend a lot of time trying to undo the effects of the inlets when we try to do a wind tunnel test. So I'm not going to do that. I'm going to make this distance just 2 inches. So equals, I don't have to do equals, it's 2 times 25.4 millimeters per inch. And that'll give me all I need to make a good wind tunnel model. Okay. Normally you have to hit the green check box. Something I did made me exit anyhow. But that's all I really need for my wind tunnel model to get a good aerodynamic representation. Drag is always hard in the wind tunnel. As I say, putting inlets on the model kind of messes up the drag and may even mess up the lift. So we'll get a cleaner estimate of lift and a reasonable estimate of drag from this model with the inlets, or with the strakes that I've created, and without the actual inlet shapes. The reason for that is because there's flow through the inlets, and then there's engine boundary conditions and all kinds of things that complicate it. Alright, so the front of the airplane looks pretty good now. Back of the airplane doesn't look much like the real airplane, and there's some issues with putting in the wind tunnel mount. Okay, So one of the issues is we have these, the bottoms of the vertical tails, and that's an artifact from Jet. Jet always draws the vertical tails from the 0 height line, but then in order to get the vertical tails to be out at the edge of the fuselage, we had to move them out pretty far. We want them out here when they exit from the fuselage, and that left these pieces down here. We could just ignore them. They probably won't change the wind tunnel much, but I can show you something interesting by eliminating these guys. Okay, so here's what I'm going to do. I'm going to create another plane to draw on, and I'm going to use this face back here as the reference for my plane. So I've clicked on the face. Now I'm going to insert reference geometry in a plane, and I'm going to put it at 0 millimeters. Okay, you see what I did there? So I'm creating a plane there on that face. Hit the checkbox. Now I've got a plane back there to draw on. Now, strictly speaking, you could draw on that face and it'd be okay, but it's a little cleaner and everything works a little smoother if you always make a plane to draw on. And I'm going to make 2 more planes. Okay, I'm going to make a plane right here and then a plane further forward up here. So first I'm going to switch the units. That's under Tools, Options, Document Properties, Units. And I'm going to switch from millimeter gram second to inch pound second. Okay, that's not exactly the units that Jet is in. Jet is in foot pound seconds, but it's closer and it's easy to work with in CAD. Alright, so I want to make a plane that goes right through this point. Okay, what I'm going to do, the big picture, is I'm going to create a sketch in this plane and another sketch up here, and then I'm going to extrude a cut that cuts away this part that sticks out and follows the curvature of the rear fuselage. Alright, so insert reference geometry plane. Okay, I'm going to go, I don't know, 30 inches. It's a lot more than that, but I have to go the other direction, so we hit the checkbox for flip, and it's more like 150. Oh no, it's not. It's more like 80. There, that's better. We could look on Jet because this is a specific fuselage frame in Jet. Let's try 90. Ooh, let's try 84. That's good enough. That's probably just right. Okay, so 84. Okay, and then green checkbox. Like I say, sometimes when you click somewhere else it exits anyhow. And now the last one is a little trickier. We're going to just put it right here ahead of the farthest forward point where this thing sticks out. And so we'll go another about the same distance. So that's convenient. We highlight, now I clicked it over here, I could also click it here in the drawing. We highlight plane 3, insert reference geometry plane, and we want to flip, and I think that'll be far enough. Okay, so that's good. Alright, so there's our 3 planes. Now the challenge is to draw a sketch that will cut away that piece of vertical tail without messing up the shape of the body too much. So what we're going to do in each of the planes is draw a sketch that follows the shape of the body pretty well, so that we can reasonably expect that it won't cut too much of the body away. So we'll start with this first plane we made. We'll get a rear view. Oops, that was a front view. Let's try a rear view of the aircraft. Notice it was a side view in CAD nomenclature. And I'm just going to follow this contour with a sketch with a spline. It's going to start right here at the middle, and I'm just going to follow this contour. Now, the CAD actually models this fuselage shape as spline, a smooth curve. But the drawing doesn't necessarily show it that way. So it looks like we haven't followed the curve very well, but in fact in the CAD engine we've done just fine. Alright, and then we have to do the rest of this, so we have to make a closed curve in order to do any kind of extrusion or loft. So I'm just going to put a box out here. Notice how the dashed line comes out when I line up with the other point, and how that other point automatically snapped to the center line, I hope. I'm going to click on this dot and notice that the y coordinate is 0. And the y coordinate's 0 out here as well. That's good because I'm going to mirror image this like I did before and cut away both vertical tails at the same time. So to do that, now all these little green locks, or anyhow, they fix the point on a particular reference, and sometimes they're good, but most of the time it's a pain and I don't use them. So so I just deleted them all, and now I highlighted everything by putting a box around it, and I'm going to mirror entities. Those are the ones I'm going to mirror. I'm going to mirror about this point. I'm making a copy. I hit the green checkbox. I delete the mirror line, and I've got a simple closed curve that I can use to cut away that vertical tail. Alright, exit sketch. We're going to do the same thing in this next plane. To make sure I selected the right plane, I rotated the body so I could see it better. Make sure I'm on plane 2 or plane 3, and then get that rear view, which is a side view in CAD nomenclature. Alright, so here's the next point I have to follow. Alright, so I'm going to start up here. Well, no, I started the center line. That'd be better. The same way I did the other one. Okay, I'm going to follow that black line. So I'm starting with my spline just like I built the other one. If curves are, yeah, I got my spline. If curves are all constructed the same way, it makes it easier for lofting. Again, there's all those little green locks, and in a way they're good because then if the other thing they're referenced to changes, they will change too. Many times I don't want that to happen. Okay, I went and got a line, and I'm drawing the rest of the box. Okay, that's not good. So for some reason, for some reason we don't have a simple closed curve. I don't see it. But normally it will stop drawing. Well, I don't see it. Okay, we're going to just take it the way it is. I'm going to delete that thing and delete that thing, and I'm going to adjust this to perfectly line up with the other one we drew. It looks like everything's connected. So it looks like we do have a simple closed curve. But normally when you do, it will automatically stop drawing. Okay, the point is no longer at 0, so I put in 0. I've got the parallel, so this one will be at 0 too. Very important that you do that before you mirror. Okay, highlight the whole thing, mirror entities, mirror about this point, green checkbox, delete the mirror line, and we've got our second point for deleting that vertical tail. And then the last one's going to be a little trickier because there's no black line there. There's a little bit of a difference in color that you can kind of follow. And we'll do what we can with that. Okay, we're going to draw on that plane. We're going plane 4. We're going to start with the spline. And unfortunately the spline, I'm just going to take a rear view and follow that. And hopefully that's a real good hopefully by the point we went to, the body had reached its constant shape. And then something happened over there. I'm going to hit escape and see what happened. Yeah, okay. So Control Z out of that. That was a mistake. And once we're happy with that curve, we exit sketch. Now this third one, we have to draw in plane 4, and we're going to assume that by that point on the airplane it has gotten to pretty much the shape we see from behind, and so we can just follow that. So here we are, we're drawing in plane 4. We're going to follow that thing around down to here, hit escape, do our usual box around, hit escape. So when you're, I didn't really say that, but when you're finished drawing lines, to get it to stop, you can hit escape or hit the green checkbox, and then you can draw something else or do something else. In this case, we're going to mirror entities. We're going to mirror about this point. We're going to hit the checkbox. We're going to delete the mirror line. Now it's a simple closed curve. And generally I delete all these little references as well. And exit sketch. Now, we hopefully have a pretty good set of sketches that follow the contours of the fuselage. And if we delete everything inside the sketches with a lofted cut, those vertical tail pieces should go away. Lofting means drawing between 2 or 3 sketches. Extruding, we just use one sketch and push that out into a solid shape. Lofting, we use several sketches and create a solid shape between the sketches. A lofted cut, we do just the opposite of that. Instead of adding material there, we take it away. So we select lofted cut. We click on the same point on each sketch. Yeah, it doesn't like, oh no, it's okay. Gives you the preview, but it's sure thinking a long time. I don't know why that should be so hard. And one more. There we go. And it looks right. We like it. We hit the green checkbox. And what do you know? Our vertical tails went away. Now we made some little scratches in the surface there, and you'd expect that because we didn't follow the entire length of the airplane. But I don't think we did anything too terrible that would mess up our wind tunnel model. You can look, and even though there's some little scratches, it's a lot better than having that vertical tail there. I'm sure after you 3D printed it, you could just take a little sandpaper and smooth that out. Alright, so that's got rid of the vertical tails. The next thing we have to do is put in our sting mount. This is going to go on a force balance mounted on sting. It's a 3/4 inch force balance, and that goes and the mount in the model is a 0.839 inch diameter carbon fiber tube with a 0.754 inside diameter, so there's 4 thousandths of clearance on this force balance, which is perfect. It slides in like butter. And likewise, we have to make a hole in our model that will let that 0.839 size carbon fiber tube slide in with a little glue on it so we can glue it in place. So what we're going to do is we're going to extrude a cut. Okay? So I'm going to go back here to my plane 2. I'm going to take a rear view again, and I'm going to draw a circle with a half of 0.842 is 0.421 inch diameter. Now, the problem with that is we are still at full scale. And I'm doing that deliberately because I want to show you something about being at full scale. So we're going to make this 0.84 or 0.421 inch at full scale. We imagine the wind tunnel model being 1/48 scale, so we're just going to make the radius 0.421 times 48. So I select circle. I take this midpoint here, the 0, 0 point as my midpoint. That may be not quite right. I maybe want to move it a little lower. And then my radius, here in the radius box, I type in 0.421 times 48. And it's 20.2 inches. Now, an F100 or an F119 compressor face is 38 inches in diameter and 19 inches. So this is just a little bigger than that. That's probably pretty good as an engine hole in the model as well. We probably use this for more than just a wind tunnel model. We'll use it as a display model as well. I don't like this point that I'm at. Oops, hit escape. It just keeps drawing circles unless you hit escape. So I'm going to unlock it from that point. I'm going to click on that point, and instead of -6, I'm going to go about -9. Oh, no, I'm not. Let's try -7. Let's try -7. Let's try 3. Let's try -3. Okay, so that looks a little more centered, and that's where I'm going to bore my hole. Hit the green checkbox, exit sketch. I'm going to highlight that sketch, sketch 5, and I'm going to extrude a cut. and it's going to go, I don't know, 300 inches maybe, something like that. How far should you go with your hole? Well, the hole can go on up in there pretty far, okay? That'd be just fine. The hole can go up as long as it's inside the model. So let's go 400 inches. We'll decide later where we want the force balance to be, but you don't want to push the force balance in until it bottoms out. So let's go even just a little further. Let's go 440. That seems like a pretty reasonable distance, and then we'll use less material also when we 3D print it because it'll just have a hole there. Okay, so that's the hole we're going to cut. So we cut that hole, that's good. Okay, and now there's still some weirdness back here. Plus, if we put the force balance here, which is where we want it in the middle of the model, then there's a little bit of sting, then the sting starts getting bigger, and so we don't want this to rub on the sting. So what we're going to do is we're going to go to plane 3, and we're going to take that circle, sketch 5, and we're going to copy it. Control C, I highlighted it, Control C, click on plane 3, Control V, and now I've got a circle there. And that's one of the things that doesn't work very well if you just draw on faces, because planes know where they are in space. Faces don't necessarily. They have their own internal reference. And so if I pasted this onto a plane after copying it from something that was drawn on a face, it could end up anywhere. But because both of them were drawn on planes, it's right where I want it to be. What I want to do with this is trim away a little more of this rear fuselage. Just get it out of the way so that it wouldn't really be there in a real airplane anyhow, and so it doesn't interfere with the sting mount. So I'm going to highlight sketch 6. I'm going to do another extruded cut. This one I'm going to draft outward. I'm going to go the opposite direction. Okay. Draft outward, and I'm going to draft outward a lot. I'm going to trim away all that rear fuselage that I don't really need, and right about to there. Might even go further and trim away some of the it's only 17 degrees as it is. I'm going to go right to there. Okay, so that clears out the rear fuselage, makes the wind tunnel model a lot cleaner. Probably closer to the actual geometry of the airplane as well, although the details of the rear fuselage are hard to model in Jet. I'm also going to use plane 4, which is further forward, and I'm going to do another extruded cut drafting outward, but not 17 degrees, just to make sure the sting doesn't. The rear of the force balance is somewhere here. Probably it's 4 inches long, and I want that to be. I don't want the sting to hit the model at all. So I'm going to go up here to plane 4. I'm going. Yeah, plane 4. It's hard to see, but there it is, little bitty plane 4. Up here a little further, and I'm going to, on plane 4, I'm going to Control V again, and there's that sketch. And I'm going to take sketch 7, I'm going to do another extruded cut, flip the direction, draft outward, but just like 2 degrees. Draft outward, sorry, like 2 degrees. And that'll give a little more room for the sting. This is not for drawing the airplane model, because probably the rear of the engine would be here in the real airplane. And so this hole up in here would all be pretty much constant diameter. But this extruded cut is to make sure we have clearance on the sting. So we do that, cut away just a little bit more of the model, and now we've got a nice place to put the sting mount. Alright, so this is full scale. There's other things you might do with it full scale, and so you may want to save it. So I'm going to go File, Save As. I don't want to put it there. I'm going to put it somewhere else. I'm actually going to put it in the place on the K drive where I got the Jet file. So it's df dfan AE481 and 2019 ETSCAT. I'm going to call this Wind Tunnel Model Full Scale. And in our next video, we'll show you how to scale it down and finish making it ready for the wind tunnel.